Okay, welcome to Easy Anatomy. I would like to talk to you today about the cerebellum, anatomy and the function of cerebellum. So let's start first with the function of cerebellum, because understanding the function will be beneficial in understanding the connection of cerebellum. So the function is balance and the position, muscle coordination, okay, and cognitive function, and motor learning motor skills. Okay, so let me start first by looking at the general anatomy of the cerebellum. If you look here at this picture, you will see that the cerebellum has upper surface. This is the upper surface, and this is the lower surface. And the upper surface, you will see the superior aspect of the vermis is smoothly continuing with the lateral part of the cerebellum. Then the upper surface has primary fissure, which divide the cerebellum into anterior and posterior lobe. Anterior and posterior lobes. Okay, so this is the posterior lobe and this is the anterior lobe. Then you have anterior notch and the posterior notch. The posterior notch is bigger. Okay, then if you flip the picture and you go to the lower surface, you will see that there is depression, which we call it valliculum, and occupied by the vermis. And the vermis actually is has several parts, including the nodule in the anterior part here is called the nodule, and then uvula, then pyramid, and the tuber, etc. It has several parts. But let us focus on the anterior part here, which we call it nodule. You will see that the nodule continuing laterally with arm like this until it reaches to lateral part here at the cerebellopontine angle. This is folliculus. We call it folliculus. And together they form what we call it folliculonodular lobe. So this part we call it folliculonodular lobe. However, this part in the upper surface and this part in the lower surface is still posterior lobe of the cerebellum. So actually cerebellum used to be like one piece, then it's like this piece of paper, you see, everything from the anterior to posterior, then it is flipped like that, and then we have upper surface and the lower surface. We start to have upper and lower surface from the under surface here. Okay, so that's why the vermis continue together, several parts, but they continue together, and then the posterior lobe also continue from the upper surface to the inferior surface. So this is the folliculonodular lobe, which has important function related to position and balance. Okay, so this is simple illustration for how the cerebellum look like. Then the most important thing is cerebellar nuclei, the cerebellar nuclei. So if you come here and look at the cerebellar nuclei, you will find, if you cut section through the cerebellum, you start to see gray matter and then white matter, then you have nuclei. So you will see nuclei inside. The nuclei are three groups. The central one here, which we call it fastigial nucleus, this is fastigial nucleus. Then the intermediate one, these two we call them interposed nucleus, which made of two parts, one called the globose nucleus and the ampuliform nucleus. The globose and the ampuliform. So the globose and the ampuliform together, they form what we call it interposed nucleus. Okay. Then the most lateral one, which look like teeth, this one sharp, we call it dentate because it look like teeth, dentate nucleus. So those are the three groups of nuclei. We have the central one, fastigial, the intermediate one, interposed, then the lateral one, we call it dentate nucleus. So let us move forward to see the input and the output of this nuclei, because this what explains the function of the cerebellum. If you look carefully here at the output and the input, so this is the input, the lower figure here is the input, and the upper one is the output. This one is the output. Output, it means the efferent, the one coming from the cerebellum to other parts of the brain, and the input, those are the afferent. So this is afferent and this is efferent. You will see unique arrangement. You will see unique arrangement. Here, the fastigial nucleus, it is connected to spinal cord, send efferent to spinal cord, we call it medial descending system or medial cerebellospinal pathway. So this is the fastigial nucleus, and the intermediate send also to spinal cord the lateral descending system, and those two systems are important for execution or starting motor activity or activity or movement. Okay, so again, this we call them together spinocerebellum. Then laterally, you will see that the dentate nucleus is going to send efferent to motor and premotor area in the cerebral cortex. Motor and this is for motor planning. So there is a planning stage for the movement, and there is execution stage of the movement. To execute the movement, to plan the movement, this is a higher function. To plan for the movement and to have fine arrangement for the movement, you have to have connection with the cerebral cortex. And this is from dentate to cerebral cortex. And to execute the movement based on the information coming from the higher center, which is cerebral cortex, you have to have connection with the spinal cord. And this connection through two tracts, the medial descending and the lateral descending tract. The medial originating from fastigial nucleus, the lateral originating from the interposed nucleus. And this is what we call it spinocerebellum. However, the system which coming from the dentate, we call it what? Cerebrocerebellum. Okay? Is going to be because it's related to cerebellum. Then we're still missing the important one, which related to one of the most important function of cerebellum. This is the folliculonodular loop, and this part of we call it vestibulocerebellum. And this is again the folliculonodular loop and the part of the fastigial nucleus, also connecting to the vestibular nuclei, and this is responsible for balance and eye movement. Okay, so we have this one cerebrocerebellum, the lateral, this one vestibulocerebellum, and this one spinocerebellum. So this is a functional division of the cerebellum. The functional division of the cerebellum, then you have one spinocerebellum, two cerebrocerebellum, three vestibulocerebellum. This is for execution of movement. This is for planning and motor learning. This is for balance and position. Okay. How about the afferent. So cerebellum has to receive some afferent, okay? Some information especially related to the position of the body. Information related to the position of the body, and information which you considered as higher order coming from the cerebral cortex. So the information bringing the system which bring information related to the position of the body and the balance of the body, those are again the afferent coming from spinal cord. So the afferent coming from spinal cord through what we call it spinocerebellar tract. Spinocerebellar tracts. And those are the tracts which present information to the cerebellum about the position of the body and the balance. And also coming from vestibular nuclei, from spinal cord, and from the eye. So basically this is spinocerebellar. We have three systems: the dorsal spinocerebellar tract, the ventral spinocerebellar tract, then the cuneo-cerebellar tract. The dorsal and the ventral, they are bringing information from the lower extremity and the trunk. But the ventral from lower level, starting from T12 to lumbar 5, and the dorsal from higher level extend up to C8. Okay, cuneo-cerebellar coming from the cuneate nuclei, and again this is related to upper extremity. Okay, how they enter the cerebellum? The dorsal enters the cerebellum through the inferior peduncle, and the cuneo-cerebellar also through the inferior peduncle. However, the ventral through the middle cerebellar peduncles. And this is something I should point to. Those peduncles are the arms which connect cerebellum to brain stem, the superior one. So if this is take me to talk about peduncles, so I'm sorry if I missed it at the beginning. The peduncles, you have three cerebellar peduncles. The superior connects cerebellum to what? To midbrain. The middle connects cerebellum to pons. The inferior connects cerebellum to medulla. Okay, so those are cerebellar peduncles. And again, the inferior, the afferent coming through the inferior, the dorsal spinocerebellar tract, cuneo-spinocerebellar tract, cuneo-cerebellar tract. Superior peduncle receive the ventral one, okay, ventral spinocerebellar tract. The middle peduncle is the main entrance for cerebellar tract coming from cerebrum. Okay, the cerebellar tract, or sometimes called corticopontocerebellar tract. Okay. In addition, of course, through the inferior also, there is olivary nucleus send information, and vestibular nuclei also send information, reticular formation. So the inferior peduncle considered to be the main entrance for cerebellum, the main entrance, because receive information coming from spinal cord, receive information from olivary nucleus, reticular formation or reticular nuclei, Okay. Going back again, if I go back here to look at the afferent, as you see, the lateral part here receive afferent from cerebral cortex. It's a reciprocal, like it's back and forth. Like the part which send information to spinal cord receive information from spinal cord. The part which receive information from cerebral cortex send the information to cerebral cortex. So here is cerebral cortex to lateral part, and then spinal cord and the trigeminal area sending information to the intermediate. This is the one. And the cortico, this is the one, the lateral. Then the fastigial part and folliculonodular loop is communicating more or receive input from the vestibular and visual and auditory input. Vestibular and again visual and auditory input. Because the function of this part is primary what? Is primary balance. And the function of the lateral part is what? Because connected to cerebral cortex, planing. And the function of the intermediate part is what? Muscle tone and execution of movement. So this is explains the connection. Okay, what is next? We need to go and emphasize important information related to cerebellum here, which is cerebellum. There is good fact you have to know. Cerebral cortex control the movement of the opposite side of the body, correct? However, when it comes to cerebellum, cerebellum control the movement of the same side of the body. How this happen? You will notice something unique. Cerebellum does not have direct connection to spinal cord. There is no direct connection. Usually cerebellum does not send directly to spinal cord. Cerebellum is not going to send any information direct to spinal cord, because its function is to compare the current position of the body and the planned movement, and then getting rid of any mistakes to reach to nice coordination of the movement. So the cerebellum is intermediate here between cerebral cortex and spinal cord down here, and the spinal cord down here. So it is intermediate. But at the end of the day, you need to keep in mind that cerebellum is going to control the movement of the same side of the spinal cord. Let us see how. You see the dentate nucleus? Dentate nucleus does not send directly information to cerebral cortex. Instead, it sends to the opposite side of the cerebral cortex. This is through the thalamus, the VA and the VL nuclei of the thalamus, and here is the dentate nucleus projecting to the thalamus. If this is the right side, this is going to the left side. Then you need to follow up with this red color, the red color. So this is the output going to the thalamus on the other side. Then from this side of the cerebral hemisphere is sending the corticospinal tract, which descend until it reaches to the medulla, and there is going to cross to the opposite side, which is the same side of cerebellum. So if this is the right, okay, this is left, okay, then at the end of the day I'm going back, this one going to the right side of the spinal cord. This is a spinal cord. Okay, the same with rubrospinal tract. This is corticospinal tract, which is going to the opposite side. How about this green color? The green color is going where? Is going to the red nucleus, and from red nucleus in the opposite side, again the rubrospinal cross to the opposite side, which means the same side of cerebellum. So here is the cerebellum. We start from right side of cerebellum, going to the left red nucleus, and then going to the right side of the spinal cord and the right side of the body. So this is again how cerebellum at the end of the day control the movement of the same side of the body. So same side of body. This is different from cerebrum. Cerebrum control the movement of the opposite side of the body. I hope that this is understood. Okay, one final thing. So what is the functional, before functional deformity, the blood supply of the cerebellum? Blood supply of cerebellum. Blood supply coming from vertebro-basilar system through three arteries. Two going to the inferior surface and one going to the superior surface. You have the first one, which is called the pica, posterior inferior cerebellar artery, or pica, and we have pica syndrome. Then the anterior inferior cerebellar artery. Okay, and from the name, or ICA, from the name, this is the anterior part of inferior surface of cerebellum, and this one supplies the posterior part of the inferior surface of cerebellum. And then the last one is superior cerebellar, and this is coming from basilar artery, okay, supplying the upper surface, superior surface, thus inferior surface. Okay, those are supplying inferior surface, these two, but this superior surface. Cerebellar syndrome is called the ataxia, and the ataxia referring to failure of coordination of the movement. So the movement become not well coordinated. So the ataxia, what is ataxia? This is cerebellar dysfunction. And they refer to loss of movement coordination. And it can summarized in group of medical terms. First, dysmetria, okay, dysdiadochokinesia, then dysarthria, okay, and tremors, So what are those things? Like when we talk about this groups of dysfunction, what are they referring to? Basically, due to, of course, loss of balance and the loss of muscle of coordination, you will find that the patient, okay, cannot touch. Like, for example, here is the pen. If I am coming to touch this pen, if I ask to touch this pen, my finger started to get tremors, and this is what we call it intention tremors. And also, I miss the pen. I am not going to touch the pen itself. So basically, this is the dysmetria. This is because if I am losing the coordination of the muscle. And this dysdiadochokinesia, I can make, like, here is my hand, I can do two different movements at the same time with no problem. And what happened, this alternating movement is going to be lost. or the patient become very slow. Dysarthria نتيجة because due to loss muscle or loss of the lost coordination between the muscles of the tongue, muscles of the lips, so the speech becomes slurred and slow. Tremors, as I mentioned, this is the intention tremors. Is not like Parkinsonian disease, which usually is tremors during rest. So keep in mind that this is what we call it ataxia, and again keep in mind that the cause of ataxia, it can be different. It can be viral infection, it can be stroke, it can be trauma, brain trauma, it can be due to several reasons. How you test this? There are different clinical tests like finger to finger or finger to nose test. If you ask your patient again to touch two fingers or touch the tip of the nose with one finger, is going to again to fail, because what happened, the finger started to shake around the target point. Okay, and this is the tremors and also the dysmetry at the same time. If you ask the patient to do alternating movement like supination and pronation of the arm, is failing to do that. And there is a test which is called the Romberg test, and this test, if you ask your patient to close the eye, extend the arm in front of the body at the same level of the shoulder, okay, then ask him to move while he is closing the eye, he is going to lose the balance. So you will see that he is swinging and he cannot control the balance. And also there is heel to shin, the test when you ask your patient to touch the shin of the leg by the heel, with the heel, is going to miss the point again. So there are different tests too for ataxia. I hope that this is clear for the cerebellum, and this is just an overview. I hope that is going to be helpful. Thank you.